All right, so the problem that's up on the screen, it's actually a sneak peek at a test question tomorrow. And so students often like to think about this in the comfort of just the classroom right now instead of like the discomfort of a test tomorrow. It has to do with the graph that's on the board with the A, B, C, D, E, F, G. And somehow you're to try to figure out which letters go with which calculus statements. You're welcome to sketch or write anything that you want, but I thought we would look at this briefly before we do the typical quiz. Now, the good news is we have talked about this. You just have to realize how each of these calculus statements represent some type of behavior, of a graph. Now, I've seen different sort of reactions to this. Some students are like, yeah, I know exactly what you're talking about here. Sometimes kids are like, that's all it is. And sometimes you're still trying to figure some things out. I want to try to get you to the point that you realize that's all it is. Okay, because each one of these statements up here refers to something that we've either said or visualized. I'm going to let you think about them, but I help you out with the first one. It says that f prime of x. Okay, now remember, it kind of goes back to our silly little chant, but if I say derivative, you say slope. That's what number one is. It's a statement about the slope. It's a derivative. It's like one of the big ideas of this year. So it says the slope is positive, okay, in its own symbols, right? So the slope is positive means that if we picture tangent lines, they're obviously going to be tilted in a positive manner. It also means that you could be going up on your graph, but all those are the same thing. And so these sections and these sections both represent positive slopes. Okay, again, because the derivative is greater than zero. Actually, I guess because the tangent line is tilted in a positive way. Now, for the sake of the way I'm trying to get you to write your answer, you would give your answer as a point. So you can basically say that point A is a place where the derivative is greater than zero, and so is point G. I'm just having you give your answer as a place instead of like an interval this time, instead of an interval where you use like infinity. So A and G. Now, can you figure out what points would satisfy any of these remaining calculus statements? Again, you're not giving the answer as an interval, rather just separate points. So you might be listing multiple points. Feel free to discuss if you want. Or maybe you just kind of want to give it a shot, and then we'll see how you did. The second statement, the derivative, the slope, is negative. It just means the graph's going down. It means your tangent lines would have a negative tilt. So CD and E, all satisfy, or all points or places when that's happening. And then the third statement is still a statement about the slope. It's also kind of one of the main ideas, that is, when a slope is equal to 0, in other words, a tangent line is horizontal, that's always going to happen at an extreme value. So the third statement is really just fancy talk for where are the extrema. So it has to be B and F. It has to be B and F. I'll just give you a few more moments if you're pondering the last three, because those have to do with concavity. The last three have to do with concavity. So number 4, if you talk about a double prime or the second derivative, it's a statement about concavity. And when it's positive, that means it's concave up. By the way, did you like my little joke from that email? I thought that was kind of funny. Are we keeping things, do we have a positive slope and keeping things concave up? Okay. I don't know. I don't usually get a kick out of myself, but I thought that was pretty good. I might have to repeat that sometime. Positive concavity is concave up. Now, do you realize that there's actually 3 places that the blue line overlaps? E, F, and G. Don't leave out F. It's all concave up. Okay, so all 3 of those places, E, F, and G. And then we just kind of have the reversal here where it's concave down in here. Now you'll notice that point D has been left out because that's the place where it changes. So we have ABC for concave down, but point D, now I'm not going to draw a tangent line at point D, that doesn't make sense, but because my orange and blue switch, that's going to be a second derivative equal to 0. That's going to be that inflection point. In the fine print for blue and orange, we kind of have that idea that sometimes students are like, do you realize what the teacher's really saying? So the orange fine print, I mean this, double derivative is less than 0 also means that first derivative is decreasing. That basically means that these tangent lines in this orange section keep getting smaller and smaller. Here it's steep, less steep, 0, and now it's becoming negative. So this is not a typo, but it doesn't mean the same thing as the red statement. To say the slope is decreasing is not the same as the slope is negative. Again, slope is decreasing is talking about these lines becoming more and more negative. And it's just the opposite for the blue section. On the test tomorrow, there'll actually be an ABC problem where I might give you two of these statements. You know, like I might say statement number 1 and statement number 4. Or maybe I'll mix other ones. But if I do say statement number 1 and statement number 4, you'd have to give the region where both of those are happening. And it would only be at point G, just for example. I give you one of those to practice in the review, but I will probably give two of these statements